Previously, we looked at a new 3D print chassis for the PCB version of our own build 8-bit system, getting ready for the Liverpool MakeFest exhibition event. A second machine was also constructed and shown. This was the long-awaited advanced colour version of our TinyBASIC computer system. Hello and welcome back to TinyBASIC Computers, the homemade 8-bit programmable computers series from youtube.com/Wi-Fi Sheep, where we're building easy to assemble, low cost, real programmable computers. If you're brand new to Wi-Fi Sheep and this project, then do check out the TinyBASIC Computers playlist, which has all the projects so far. Last time we assembled one of the PCB board TBC builds onto a custom 3D printed chassis in readiness for the Liverpool MakerFest exhibition. By the way, a big thank you to all of you that did make it down to Merseyside for the show. Now on display that day alongside the breadboard and PCB versions was the first build of our concept colour version of TinyBASIC. The revision 2 PCBs used for both systems were made for us by our project partners PCBGoGo.com. PCBGoGo manufacturing bases are equipped with the most advanced production equipment such as Yamaha pick and place machines, reflow ovens, wave soldering machines, X-ray and AOI testing machines, all operated by highly skilled technical personnel. Their factories and world-class production facilities have over 10 years of experience in the PCB industry, serving Chinese, domestic and internal markets. PCBGoGo is a leading specialist in surface mount through-hole and mixed technology PCB assembly and electronic manufacturing services, as well as turnkey electronic PCB assembly. PCBGoGo provides easy and cost-effective online ordering services from prototype to mass production. So join today. Sign up for your free account today at PCBGoGo.com. Ever since the TinyBASIC project started back in 2020, many of you have asked for upgrades and a more advanced system. To date, I've been reluctant to implement too much of this, mainly due to incurring extra cost, but also the dreaded feature creep that has seemed to have currently dogged a fair few similar projects out there on YouTube. However, even I have to admit a few extra key features would be nice, the main one being colour. In this case, a higher resolution colour output at around 256 colours and 640 by 480 pixel resolution. A USB driver for driver support, so most USB keyboards including Apple products could or should now work and not rely on the older IBM PS2 protocol. SD card support with the ability to read and write saved ASCII encoded TinyBASIC source code direct from or to FAT formatted SD card. And finally, the adding of some missing key basic commands such as delete, backspace, CLS and in key, as well as custom commands for controlling colour and graphics. Now, as mentioned, the build for this is already done and had to be done quickly to be ready for the Liverpool MakeFest event. As this is very much an early development system, it's not really ready to be shown in the step-by-step how to build videos just yet. However, I will go over briefly what I did to build this new colour system. As with the previous build, I started with a set of my custom 3D printed pegboard chassis to mount the components onto. Here you can see the layout incorporating one of the custom revision 2 PCBs, a small breadboard and a few other notable additions, including a recovered Raspberry Pi Zero, a 5 to 3.3 volt level shifter, and the two key parts we'll retain on the original R2 PCB, the Arduino Nano and a small PC speaker buzzer. For this build I needed to isolate the USB data lines, so using a cutting disc I made a small cut to break the copper tracks, I can assure you my thumb is not as close to the disc as it looks in the picture. With that done and a bit of tape over the cut, I set about soldering the required components to the main PCB board. The Nano itself I attached to some female pin header, as I want to be able to remove the Nano as required. Just using some alcohol based flux here before soldering the Nano header pins in place, starting with the corners. Now, although I'm not going to fully populate this board, some pin jumpers are still required, mainly for the sound line selecting, so I'll just add what's needed. Okay, so turning my attention to this, a reclaimed Raspberry Pi Zero, which is going to be at the heart of allowing use of full colour. This one works fine, it just needs a bit of a clean up. Now I'm going to use wire wrapping cable or wire, which is normally used for PCB repairs or bodge jobs. In my case, I'm going to use it to wire my Revision 2 PCB to the Raspberry Pi Zero, the Pi taking the place of the Atmega 328P chip normally used as a terminal and video out. Let's take a look at the 3D printed chassis. I require two build plates which are designed to clip together to expand the work or mounting area. To make sure these are secure, I'll use a small amount of super glue as it's the only thing that seems to stick PLA plastic together. And now to mount the two PCB boards. At this point I've just attached the two USB data lines, but many more wires will follow. I'm going to secure these with small self-tapping screws. Now, because I'm not 100% on what additional components I'm going to need, I decided to add this small solderless breadboard. These all come with a self-adhesive backing, so it can be stuck down to pretty much any surface. Now, as explained, the Arduino Nano uses 5V TTL logic, and the Raspberry Pi uses lower 3.3 volt standard, meaning you need a level shifter to drop signals to the correct voltage to safely use. I'll just add some jumpers to create the 5V and 3.3 volt power and ground rails. I'm also going to add two 10UF electrolytic capacitors, one to each of the power rails that act as smoothing caps to aid minimising noise and interference on the UART serial lines. And this is a little bit later. As you can see, the bulk of the wiring is now in. Although with the data lines for USB, I also take voltage ground TX RX UART serial lines via the level shifter between the two main PCB boards. Remember, the Raspberry Pi is now doing the heavy lifting of being our video out, USB driver and dumb terminal. So finally here I'm attaching the mount for the composite video and audio RCA phono jacks. I'm going to use one of these audio plates, which I notice now include a common ground pin, which is useful. Okay, so that's wired in. Audio is coming from the original R2 PCB and video is coming from the TV pin on the Raspberry Pi Zero. Although I think this pin got removed on the later Raspberry Pi Zero 2 boards. Two bolts hold the RCA phono plate onto its 3D printed mount, and that just needs a little bit of tightening up. And here is the completed Generation 1 prototype for the colour system. As I've mentioned, it's a little bit rushed together because it was needed for the show, but it does work surprisingly well. Now, a couple of key features which make this different is obviously the inclusion of a Raspberry Pi. Now, I have to stress the Raspberry Pi is purely running as a video terminal and a USB driver using an open source bare metal terminal program called PiGFX, or PiGFX for short, and that's open source and free. And I have it here on an SD card which goes in, and obviously it boots. Now, it's not booting Linux, it is running bare metal, which means this thing practically acts as a second microcontroller. The huge advantage is because it's the Raspberry Pi, in this case the original Zero, is it's powerful enough to run a basic USB keyboard driver. Meaning, for the very first time for this system, we can actually plug in non-PS2 compliant USB keyboards. And that includes Apple keyboards, and they will actually work with this. So we can put the USB in. That's why we cut the tracks to reroute where the USB goes, so it's no longer needed on this side of the system. I have to stress it's still at the moment the Atmega 328P on here, on this Nano, that is doing all the work. It is running as the 8-bit system. But the Pi now adds colour, USB support and high resolution. It also means that we can run via HDMI for the very first time, just by plugging into the Pi's HDMI out. Or we can still go via composite, and there's composite audio and video here. The composite is now coming from the Pi, which means it can do high resolution, both NTSC and PAL, although that is now set in the config file of PiGFX, not by pulling lines high or low over here. The other big change is that we've now got a micro SD card reader, and we're able to load basic programs on and off SD card. Here is the SD card. Now it's formatted as FAT32 or FAT16. They're the only two formats that work. And I have a series of text ASCII based .bas files or .bas files, which are the same as .txt but .bas for basic. And I need to put the card in before we power up the machine. There we go. Now, as for powering up the machine, originally it was still intended to power up through the USB here on the Nano, but by the time the voltage gets over here, it's actually dropped below 5 volts. So it is now better, if possible, to power through the Raspberry Pi. And that'll, of course, jump the power back the other way. So without further ado, let's power up. And I'll show you what it looks like on screen. As you can see, it boots really, really quickly. And this is TinyBASIC Computers for Color. And this is version 4.02 Alpha Color Build 2. Now, because we've still only got the 1K of usable system RAM available, and we're now running a micro SD card filer system, unfortunately that now takes more memory out of our 1K, meaning the system only boots with 263 bytes of RAM. And I appreciate that is beyond limiting in what you can actually do. Now, there's been a few upgrades, and one of them is we can actually backspace, which you couldn't do on the previous system. So that's really, really cool and really helpful. So if I make a mistake, I can actually generally backspace, and that now works. So if I now go mem, as you can see, 263 bytes of RAM available on startup. There is no built-in EEPROM. Not that the Atmega 328P can't support one or doesn't have one on board. It's just the fact that I don't intend to stay on this chip architecture for the colour system. So we're going to have to assume that chipsets that we're going to jump to are not going to have onboard EEPROM. So I switch that function off. Plus the fact you don't particularly need it. Now you've got a working SD card library. Okay, so we can now load something off the SD card. Now I have to stress, because I'm running such few bytes of RAM available, the system is a little bit unstable. So normally I could type load and then my file name and then run the program. This will crash at the moment. So if I want to run, for example, demo.bas, I have to chain it. So chain demo.bas, and that will actually run the demo code. Now I've managed to squeeze this into the available RAM. The only way of doing that was that it actually chains new programs in each time. So we do actually have a guess the number game, we have a binary scroll demo, and we have a color test. I'll show you color test first of all, so option 3. And here is all the available colors. It's 256 colors on the palette, and you can see how the background color can dynamically change. We should be able to list that source. There is the program, and I can run again. Incidentally, we now have commands such as CLS now works for clearing the screen, which is great. And so we're beginning to get the flexibilities of a relatively, I would say, modern computing system, but usable retro style computing system. Okay, let's clear the memory out and we'll chain back into menu, or demo I should say. Chain demo.bas. And let's try the binary scroll demo, option 2. And this is pretty much what I was running on this system at the Liverpool Make Fest, because it was colourful and it kind of did something, but it kind of shows you the kind of simple, effective type programs that you could do even in this tiny, tiny amount of RAM. So we'll escape that. And again, I will show you the listings There you are. There's the listings for that. So yeah, it works okay. It's quite simple basic. And how much memory have we actually got left in the system? 132 bytes available. So it's only taking up about 100 and odd. 130, 140 odd bytes of RAM. That not bad at all. Let's go back to the demo again, and I'll show you now option 1. So what number I'm thinking of, and you've seen this before, but unfortunately I've had to take the sound drivers out. So though we do have a little buzzer here on the system, I've had to remove the sound driver just because there just isn't the RAM to run the sound driver and have any space left. I mean, this program alone is crammed into 200 odd bytes. Let's just see if I can win the game. You can see it is actually being able to pick the colour. So correct, new game. 1 is yes, 2 is no. So oops, I've said 3. Anyway, so if you go more than 1, it actually says no and finishes the game. So let's see if we can list that. And no, we can't list it because that's when the program has started to, or where the computer's now crashed because it's getting confused because it's just hasn't got enough RAM to execute properly. So we're really at the end of what the standalone Atmega 328p microcontroller can actually do for us, especially if we're trying to run more advanced color systems. I've just hit the reset button and you'll see it actually does a system reboot. And there we are, comes back up again. It's a little bit slower to reboot than the earlier systems, but fundamentally, there it is, and it is working okay. One last thing I'm going to show you is something called Key ID, which is another feature we've added into BASIC. So I'm going to load this one in because it's a very small program. So load, and it's keyid.bas. Oops, I've not spelled that right. And you see what happens if it can't find the file. So let's try that again. Load keyid, there we are, .bas. Okay, that's now worked. I should be able to list this. I can. And you can see it actually uses the in-key statement, which is not currently present in all the current versions of TinyBASIC that have been released via the Wi-Fi Sheep, either Facebook group or Patreon. So if I run this, if I now hit a key on the keyboard, let's just bring my keyboard into view so you can see it. So if I hit Q, for example, it'll tell me that that is the ASCII code 113. So it can now read directly the keyboard, including the space bar, numbers. It'll tell you what the keys are on the keyboard. This will be very, very useful for writing games, for example, where you want to move a character around the screen. And that will be possible as I'm going to be putting commands into BASIC to be able to write and draw things to the screen in certain places. That's very different to what we've had previously. When we're done, we can hit escape. Now escape code is 27, but it will also break and escape the program. And we can list again. And we could check to see how much memory that leaves us in the system. 174 bytes left in the system. So yeah. And I can CLS, clear the screen if I want. If I type by, it'll just restart the BASIC interpreter. So there we are, TinyBASIC computers for colour. As you can see, the system is still in its infancy and has a lot of issues. The main one being RAM and the lack of. Meaning I think we're coming to the end of the road for the Arduino Nanos and Atmega 328p microcontroller chipsets. Yes, some 32-bit chips like the ESP32 or even Raspberry Pi Pico would be a logical place to go, but I would still really like to try and stay with a true 8-bit processor, if at all possible. For those of you still building the current systems, do not worry, there's still plenty of life in them, and I've been doing some development for these. A new update for Patreon backers is coming very soon and will include a new updated version 3 hex ROMs and the alpha quality version 4 color ROM you've seen today. If you want to give it a try, but I stress it's not supported or even documented fully, and it's very, very buggy and likely to change substantially over the remainder of the year. So if you've not done so already, you can join the General Support and Downloads tier and get access to the TinyBASIC Computers Toolkit. Links are in the description, or visit patreon.com/Wi-Fi Sheep. That's patreon.com/Wi-Fi Sheep. Alternatively, free download 2.0 hex ROMs and build instructions can be found by joining our TinyBASIC Computers Facebook group, which can be found at facebook.com/groups/WFS TinyBASIC. Make sure you keep it subscribed here to Wi-Fi Sheep on YouTube for the latest from our TinyBASIC Computers project, and I hope to see you real soon. As always, thanks so much for your company, and bye for now.